Our next section is on exponentials, and we're going to be looking at taking a to the n power and kind of looking at what that means. A is called your base, n is called the power of the exponent, and really what this means is we're doing repeat multiplication. So for example, if I have the number 5 to the third power, that's just taking the number 5, multiplying it times itself 3 times, and coming up with the number 125. Same for a variable. If I take x to the 4th power, that just means we're taking 4 x's. It's a short way of writing all of this down. All right. So with this idea, we're going to look at some properties and laws of exponents. One of them is this idea: any base to the 0 power is equal to the number 1. Okay, so if I take 5 to the 0 power, that's equal to the number 1. And the reason for this is, let's think about a pattern here. If I have 5 to the 2, 5 to the 3, 5 to the 3 is 125, 5 to the 2 is 25. To get from here to here, we drop it by a degree, we went from 3 to 1, and we divide by 5. Drop it by a degree again, and we divide this number by 5. Drop it by a degree again, and 5 divided by 5 is 1. And that works for any base when we raise it to the 0 power, with the exception of the number 0. 0 to the 0 is an indeterminate form, so we don't talk about that one in this course. But any other number to the 0 power is 1. And we have to be careful because we've got to recognize what our base is. If I have negative 3 to the 0 power, our base is negative 3, raised to the 0 is 1. However, if I have negative 3 to the 0, my base is just the number 3. In fact, this is the number negative 1 times 3 to the 0. That's negative 1 times 1, and my answer becomes negative 1. All right, so it depends on whether the negative is inside or outside of the number. In general, if the base is any number, with the exception of 0, our answer is 1. But you have to recognize what is the base and what is not the base. All right, so from here, we can talk about laws of exponents. And we'll go through a few of these laws and then take a look at some examples. With the laws of exponents, one of the laws says that if I multiply like bases together, a to the x, let's use m and n. I think that's what your book uses. A to the m times a to the n is equal to a to the m plus n power. If I multiply like bases, I add the exponents. It makes sense if you write it up, x to the third times x to the 2, and remember that this is repeat multiplication. So x to the third is 3 x's, x to the 2 is 2 more, so all total I have x to the 5, or 3 plus 2, which gives me 5. For the second rule, I have division. A to the m divided by a to the n. Well, if multiplication was addition, division is going to be represented by subtracting the powers. And again, if you think about this in terms of canceling, if I have x to the 5 on top and I have x to the 3 on the bottom, that's 5 x's on top being multiplied together, 3 x's on the bottom. And because they're on top and bottom from each other, and it's all multiplication here, I can go ahead and cancel an x for an x. One on top, one on bottom. Again, one on top, one on bottom, one on top, one on bottom. So what I'm left with is 2 x's, or that x times x, and on the bottom it's not 0, but it all actually canceled out to the number 1. This works out to x squared, or 5 minus 3, which gives me the x squared. The third property looks like this. If I raise a power to a power, I multiply the powers together. it's kind of, if you want to think of it as distributive property, but not really. But it does get rid of parentheses like the distributive property does. When I multiply, that goes ahead and gets rid of that parenthesis, and I'm left with a to the m times n. If I think about a real life as in terms of math example, if I do x to the third taken twice, this means take x to the 3 2 times. Well, that means write down x 3 times, and then write down x 3 more times. All multiplied together, and all total give me x to the 6th. The easy shortcut way, and that's the way we're going to remember this rule, is you just multiply those together to get that power. So let's try a couple of examples here. Let's do one more property. This is kind of a key one because sometimes things don't always come up nice and positive. If I end up with a negative exponent, we're going to simplify that to 1 over the positive of the exponent. And to do that, if you think about it, you're taking the reciprocal of a, which is 1 over a. Another way to think of it is this. If I cross the line, I change the sign of the exponent to its opposite. If I'm wanting it to be written as a positive exponent, all I have to do is cross the line, take the base down, and it'll change the power of the change the sign of the exponent. So for example, 5 to the negative 2 power, think of 5 as 5 over 1, cross it down below the line, and we can't have topless fractions in the state of South Carolina, so we're going to make it 1 over, and then 5 squared is 25. Notice that didn't change the sign of the number, it just made it 1 over, the reciprocal. So you can think of it as 5 squared is 25, take the reciprocal, 1 over 25 as your final answer. That goes this way too. If I have something in a denominator that has a negative exponent in it, let's make it a negative 2. If I cross the line above the division bar and move it up to the top, it changes the sign of the exponent. 3 squared is 9. So you can go, it's like a toggle. It'll switch it back and forth to its opposite sign. Now if it's already positive and I move it up across the line, it's going to make it a negative exponent. But I don't want negative exponents in my final answer. I only want positive exponents. So that's the notes from the section P2. I'm going to give you a few more examples in the next video.